Okay, this one. So, क्या था recap? The recap was yesterday. We did this thing. We did alkenes. Okay, there was pi bonding in alkenes, and we did sp2 hybridized carbon atom. Okay, they were overlapping. They would form sigma bonds, and they would form sigma bonds and a pi bond in the middle, right? And the thing I told you was that the electron density in the pi bond was very high because it was a very concentrated charge density. So there was very strong attraction for electrophiles. And then you had benzene. In benzene, you had three alternating double bonds. And this was not the correct representation. What happened was that when you had three alternating double bonds, it was six sp2 hybridized carbon atoms, all forming sigma bonds in the middle, and they were p orbitals, and the p orbitals they started overlapping, and all of them ended up overlapping with each other, which is why you had a ring of benzene. Okay? So you had this ring of benzene. So I need a benzene shape. Just a second. Let me see if, yeah. Okay, this is how the benzene looks like, the skeletal formula of benzene. And it's got a ring of delocalized pi electron cloud. Okay. So that's what benzene is. And I told you okay, in benzene, the difference between the double bonds in benzene was that the electron density was not very high. It had a lower charge density compared to alkenes. There was less attraction for electrophiles, and therefore it was more stable because it wasn't attracting anyone. It wasn't very reactive. So the so it was very stable. It wasn't really going to do a lot of things. So it was a lot more stable structure compared to alkenes. Alkenes are way more reactive because they've got a higher charge density. ठीक है तो ये सर is this all clear?
Yes, sir.
ठीक है. And a few more things कि remember this isn't really a double bond. What this is something between, remember this, benzene bonds. Okay, let me write it over here. Benzene bonds are something in between a single bond and a double bond. So benzene, carbon bonds, because it's partial sharing. The electron density is being shared on both sides. So benzene carbon bonds are somewhere in between a double bond and a single bond. Okay, that's in between a carbon single bond and a carbon double bond. Okay, it's something in between. If you look at the data booklet as well, where's the data booklet? Just a second. This one. So you would notice that like even in the bond energy, like if you go and open the bond energy values, you can see that you've got carbon carbon single bonds, you've got carbon carbon double bonds, you've got carbon carbon triple bonds, and then you have a benzene carbon carbon bond, which is which is kind of in the middle. Okay, so it's kind of in the middle of the double bond and the single bond. That's 350. This is 610, so that's 520. That's something that's in between. Okay, is that part clear? And let
Yes,
me.
sir.
Okay, that was your 6 mark question describing the structure of benzene, which you're going to get. I said now I'm going to move back to alkenes. So let's first revise alkenes. Okay, all that we did and all the reactions of alkenes. Okay, but very very quickly. Okay, we're not, but that's a yes revision. So we're going to revise alkenes a little bit. So we're going to talk about alkenes and the electrophilic addition reactions and the mechanism. Remember, the mechanism is also important. They're going to ask you about the mechanism. We're going to revise the Markovnikov's rule, everything about alkenes. So electrophilic addition reactions. So alkenes had a bunch of reactions. They had. So I'm just going to write the conditions first. So for example, if I have ethene, the first reaction that they had was bromination. So it was Br2 aqueous or CCl4 solvent. And in the dark. And what would happen? That things will get added to the double bond, right? So you had a double bond, but let me make it propene. Let me call it make it an unsymmetric alkene. So what's going to happen? The bromines will get added to it. So in the double bonds, the two bromines are going to come in, and they're going to get added to it. Give me 1 second, it's hanging up. Just 1 second. And what was the importance of this reaction? It was a test for identifying alkenes. Alkenes or unsaturated molecules, right? Okay, or you'd already know this. The red brown, what happens? The red brown orange bromine decolorizes in this reaction. Okay, there was a mechanism. We're going to come back to the mechanism later on. I said the next reaction. What was the next reaction? There was a reaction that was known as hydration. Okay, so you have this hydration reaction where you had water reacting in the form of steam. The temperature for the reaction was 300 degrees centigrade temperature, and there was 60 atmosphere pressure. Or क्या था? There was acid catalyst. So you had phosphoric acid catalyst. That was the preferred. It could be any acid, but phosphoric acid because it's not an oxidizing agent. So that was the preferred catalyst. And over here you had a Markovnikov's rule as well, which was that if you have an unsymmetric alkene, then two things would be produced. When water gets added, H and OH will get added to it. There would be an H attached and an OH attached on the double bond. Okay, that's one. That's propan-1-all that's getting produced. But there was another option, which was that the H and OH could get attached the other way around as well. Okay, so one of them was the major product, the other one was the minor product. So the OH could be on the left side and the H could be on the right side. Okay, is this clear?
Yes, sir.
Yes, sir. Sir,
अच्छा
can you just write the rule again? Like,
नहीं वो मैं
ये
लिखता
rule
हूँ
क्या था?
वही मैं पूछ रहा हूँ what's the rule by the way? Does anyone remember what the rule is? The
It
Markovnik.
depends on the hydrogens, right? Like,
Hmm?
कितने hydrogens attached. It does depend on the hydrogens attached.
So
Like,
the rule was that it was known as the
इससे ज़्यादा hydrogens.
Markovnikov's. It was okay, the H likes to bond with the carbon in the double bond, which already has more H's. So Markovnikov's rule was H bonds, and it only applies to unsymmetric alkenes, uh, or asymmetric alkenes. So H bonds with carbon in serial bond C, which is already bonded to more H atoms. So in the above, which one do you think is the major product? Which one is the minor product? And there was a reason for that. I'm going to come back to the reason. In this case, like if you look at the molecule, the carbon on the right side is bonded to two H's. The carbon on the left side is bonded to one H. So the H likes to bond with the carbon that's already bonded to more H atoms, which is going to be the right side carbon atom. Okay. So the second molecule that I've drawn, that's my major product. Is that clear?
Yes, sir.
Okay, that's my major product. And Saro clear, is this clear? Afan, everyone else, Ishita, is this clear? The major and minor product.
Yes, sir.
Without the reasoning, I haven't done the reasoning yet. Okay, you should know what the rule is. And then you had two more reactions. There was hydrogenation. Okay, that was an addition reaction as well. So hydrogenation was that what was hydrogenation? It was H2 gas being added, and you had a nickel catalyst, and you had the temperature was 150 or 200 degree centigrade temperature. And the molecule would become saturated. It will become, so on both carbon atoms, each atoms will get attached. And what was the importance for this reaction? It was important, useful in forming margarine. Unsaturated vegetable oils were converted or were hydrogenated to form saturated fats, basically margarine, right? So that was the third addition reaction. And then I guess there was a fourth one with hydrogen halides as well. That fourth reaction was the fourth reaction was with either HCl, HBr, and that normally happened at RTP, so it was with either HCl or HBr or HI. Normally happened at RTP. You didn't really have to do anything. The Markovnikov's rule applied over there as well, that if you have an unsymmetric alkene like propene, so you will get two products. So the H likes to bond with the carbon that's already bonded to more H atoms. This is going to be your major product. So that was your major product. And then you had a minor product, which was the other way around. The H did not bond with the carbon that was bonded to more H atoms. So in this other molecule, the H will be bonded to the left side carbon atom, and the Cl will be over here, and that's your minor product. Okay, so you had these four basic reactions, addition reactions, electrophilic addition reactions. Okay, is this clear? ये clear है सारों को?
Yes,
Yes,
sir.
sir.
अच्छा, अब next is के the other stuff. What is the mechanism of electrophilic addition? ठीक है, so how do they react? So electrophilic. So remember, A2 के अंदर electrophilic addition mechanism is like very important. It's an AS thing, but it is important in AS as well. So first thing I'm going to quickly draw the entire alkene, basically the pi electron cloud. So that's what ethene looks like. second. So that's what a typical ethene molecule looks like. And I'm just going to, because we have already labeled it, I'm just going to remove all the sigma pi bond labels. And I'm also going to make it an unsymmetric alkene. So instead of an H on one side, I'm just going to have, okay, I need to keep that bond just a second. So I just want to remove the H. So instead of the H over here, I'll have a CH3. Okay, so now it's an unsymmetric alkene. Okay, so the double bond has a very strong partial negative charge density. So what happens is that if a bromine molecule, let's talk about bromination. So if a bromine molecule comes close to it, the bromine molecule gets very strongly polarized. Its electrons are going to be pushed. They're going to be repelled. So they're going to be shown this way that the electrons of bromine are going to be repelled. The bromine molecule was not a polar molecule, but now it's going to become polar. The top bromine will become slight positive and the bottom bromine will become slight negative. The polarization is very strong. So that's the first step. Br2 molecule. It's strongly polarized. So you get a very strong positive bromine and you get a very strong negative bromine. And what the positive bromine is going to do is that it will attract the pi electrons towards itself. So when it attracts the pi electrons, it goes and bonds with, it will eventually go and bond with the carbon at the top. So, so the next step is a carbocation gets formed. So what happens in the next step is that the bottom bromine gets knocked out. It's getting polarized. It will be knocked out. And it will eventually become Br minus 1. Both electrons in the bond are going to go towards this bottom bromine. And the top bromine will become what? It will become +1. Right? So there is heterolytic bond fission that's happening. The bromine bond breaks unequally. Okay, so there's heterolytic bond fission that's happening. And the top positive bromine goes and attracts the electrons in the pi bond. And it will eventually bond with the carbon atom. So what's going to happen is that the pi bond will go away. Why? Because where would it go? All of the pi bond will be taken up by this positive bromine. And its electrons will eventually be, so the electrons will eventually be shared with this positive bromine. Right? Is this clear? And the bromine would no longer be positive because it's gotten its electrons back. ठीक है, clear?
So, sir, yes, step number 2.
ठीक है, that's I'm going to write the simplified version as well. So ठीक है. अच्छा, but that results in the production of it produces a carbocation, right? And why does it produce a carbocation? Because the double bond electrons that were being shared over here, the two electrons, they're taken up by this bromine. So this carbon over here ends up losing electrons to this bromine. But there are two possible carbocations that are possible. It could be the other way around as well. I mean, this bromine could take away the pi electron cloud and bond with this carbon atom as well. And this carbon would be the carbocation in that case. So there'll be two possible carbocations that will be formed. So instead of this one, yeah, so I'm going to rub off the positive charge. I mean, the bromine bonds with the other carbon atom. and this one becomes the carbocation. So that's known as your carbocation intermediate, and the two possibilities. Both of them will form. So that's why, what do you call it? It's a carbocation intermediate. One of them is the major one, the other one is the minor one. Although in this case, it doesn't really matter which one is the major, which one is the minor one. But even in this case, one of them is the stable one, the other one is the unstable one. As anyways, the next step is easy. Okay, what happens in the next step? This Br minus one. Okay, let's have two of them. They're going to go and they're going to attach to the carbocation. That's it. Okay, so that's my final step. And the same thing over here. So it's going to draw curly arrows, and you're eventually going to get your product, which is pretty much going to be the same product in both cases. Okay, so you're going to get a single product in this case because it doesn't really matter. Both of them are bromines. And eventually the charges are going to go away. One is negatively charged, the other is positively charged. And they'll eventually, they'll eventually share electrons. Okay? So that's it. Okay? That's your whole mechanism. So it's a two-step mechanism. You can remember it's a two-step mechanism. Uh, Carbocation intermediate is formed, and then you get the product. The first step is the slow step. And the second one is usually your fast step. Okay? And make sure you know it's a two-step mechanism. Now that's the first thing. Okay, the simplified way of writing this whole mechanism is the simplified way of writing the way you're going to write this in the paper is it's this. Okay, I'm just going to write the simplified version. Okay, detailed version is important because they're going to ask you about tiny things about this. Okay, so the simplified version is that there's a bromine molecule. Its electrons get repelled. This becomes slight negative. This becomes slight positive. The double bond electrons get attracted to the positive bromine. Next step, carbocation gets formed. So there are two possibilities. Okay, so that's so in this case, it won't really matter. Okay, let me follow the unsymmetric one. That's CH3. So you've got H, and you've got a carbocation forming, or you could have the other carbocation forming as well. The Br bonds to the carbon on the right. And this is your carbocation. And next step, the Br minus one joins in. And you're eventually going to get the product, which is what? It's CH3. I say anyways quickly. Which of the carbocation is the stable one? Yeah, does anyone remember, how do you figure out which one is the stable carbocation?
Like it depends on the methyl groups, like the electron donating groups.
Okay, the more, so remember, 2 degree, 3 degree carbocations are the most stable one. And I'm going to give you the reasoning for that. This is the most stable one. This is the one that's going to form. The other one is the unstable one. Okay, for example, over here as well, this one is the is the most stable carbocation. So I'm going to talk about carbocation stability because they're going to ask you about the Markovnikov's rule, and they'll ask you about which carbocations are. This thing comes very often, like carbocation stability comes very often in A2 papers. So you need to know the reasoning behind that. So remember that carbocations with more alkyl chains are more stable. I mean, the reasoning is with more electron donating alkyl chains, they are more stable. Why? Because they've got a lower charge density. So for example, if I have a tertiary carbocation, I've got a carbon atom, it becomes a carbocation, it's got three methyl groups. Then there's a secondary carbocation. I've got a carbocation and it's got only two methyl groups. And then I have a primary carbocation. It's only got one methyl group. So the first one has three methyl groups, alkyl groups, which are electron donating. The second one has two, and the third one has three. The way they're described is this is a 3-degree carbocation. This one is a 2-degree carbocation. It's got two alkyl groups attached to it. And this one is a 1-degree carbocation or a primary, secondary, or tertiary carbocation. Okay, this one is a tertiary carbocation. This one over here is my secondary, and that over there is my primary. I say anyway, so the primary one is the tertiary one is the most stable one. So the tertiary one, this one is the most stable, while this one is the least stable. The most stable one has a lower charge density. Why does it have a lower charge density? That's pretty obvious because it's surrounded by electrons. There are 9 electrons over here. I mean, a carbon chain has a lot of electrons. A carbon chain and alkyl chain is a big group. So when you're surrounded by electrons, the positive charge in the middle is going to be pretty much neutralized. It's not going to be a very large positive charge because it will be kind of neutralized by all the negative electrons on the other side. This positive carbon is not surrounded by large groups. Hydrogen barely has one electron. So so its positive charge is going to be a lot higher because it's not getting neutralized by it's not surrounded by electrons. ठीक है ये clear है बात सारों is this clear to everyone?
Yes, sir.
ठीक है Zaira, is this clear? Everyone else में
Yes,
Akshita
sir.
ठीक है
Yes, sir.
the reason I'm just going into a bit more detail is that this one is important in A2 as well, and I'm assuming that you've forgotten all of this. ठीक है so plus in A2 the thing with A2 is that in AS you studied this, but in AS you normally don't get a lot of detailed questions. In A2 you kind of get a lot of detailed questions. They ask you very little things as well. अच्छा, so this one is stable. This one is going to be easier to form. ठीक है this one is very difficult to form. ठीक है remember one thing. If the charge is bigger, right? Uh, then those things are really difficult to form. You know why it's difficult to form? Because for example, I want to form a primary carbocation, right? The charge is bigger. So So if the charge is really large, then those things are harder or more difficult to form. Why? Because let's assume it's got a Cl, right? So if I want to turn it into a carbocation, I would have to remove this Cl, right? So I have to somehow knock the Cl out, right? So if I knock the Cl out, the Cl will be -1 and the carbon will be +1, right? But if the carbon is like has a really large positive charge, it would be very difficult for me to knock the Cl out because there's going to be very strong attraction between them, right? So the thing is that if the carbocation has a really strong positive charge, it's not going to be it's going to be very difficult to form in the first place because it's going to be very difficult to knock out the Cl. There's going to be too much attraction. ठीक है ये part clear सारों को that why primary carbocation or forming primary carbocation is that difficult? Is that clear?
Sir, can you just repeat again?
Yeah, I'm saying कि ये तो clear है कि if you have a primary carbocation, the charge on this particular carbon is like really strong. You clear?
Yes, sir.
So I'm just saying कि forming primary carbocations, forming anything that's got a very large positive charge, that is very difficult क्योंकि uh, if I want to form this carbocation, I have to take out the Cl, right? But I have to somehow knock out the Cl out, right? The problem is
Ye-
that if the charge is very large, so
Yes, sir.
it would be very hard to knock out the Cl. Clear? There's going to be
And so about if we have two Cls attached, like we have still, it will be primary carbocation.
नहीं वो उस तरह के we're not doing all sorts of combinations, ठीक है? But let's try and keep
Okay,
things
sir.
simple, ठीक है? लेकिन ये idea clear है that primary carbocations are just going to be very difficult to form. Tertiary carbocations can be easily formed because the positive charge is not very strong. So once they form, they don't do anything. They don't start attracting other substances. So which is why your tertiary carbocations tend to be very, very stable and they're very easy to form. As anyways, that's the reasoning for Markovnikov's rule that you're going to state that carbocations with more electron-donating alkyl chains are more stable as they have a lower charge density. So that's the reasoning, and this is what you're going to write. Okay, that's your Markovnikov's rule. Okay, is this clear? Clear, Sam? Zoya, is this clear?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
So that's electrophilic addition. Okay, we did one example. That's electrophilic addition. Now what we're going to do is we're going to jump to benzene. Uh, what will this do? I mean, there were other reactions for alkenes as well. We'll do them. We'll revise them later. But how would a benzene molecule react? And what kind of reaction? ठीक है? Remember, alkenes underwent. These two are very, very similar. ठीक है? An alkene is very similar to a benzene, except that the benzene has a lower charge density. So what's going to happen if I react bromine with benzene? What would happen if I react other things with benzene? So we don't have a lot of time right now, but I mean that's a very long story. Okay, so we'll start with benzene in the next class. Okay, we revised alkenes. Achha, remember alkenes are important. Markovnikov's rule is important. Why? Because this thing is very similar to benzene, and there'll be a lot of comparison questions coming in. Okay, which is why all that we did in detail that's going to come in. That's going to be very important. Okay. So next class we'll start talking about benzene and what are the reactions of benzene and how are those reactions going to be different from reactions of alkenes. Okay, is that clear?
Yes, sir.
Yes, sir.
So same thing in next class we'll do benzene. We'll have class tomorrow. Okay, we missed one class. We'll have class tomorrow. Okay. Okay.
Allah, sir.
Take care.
Staff.
Allah.
Thank you, sir.